Welcome. Today we're going to talk about semantic context inclusion, how to build better agents that can efficiently and effectively draw from large context collections. So we're going to talk about this in the context of TsAgent, which is our TypeScript agent platform. It's a TypeScript first open source platform for building and running agents. It's an ecosystem, has a bunch of elements, including a desktop agent foundry, which is a no-code agent builder for Mac and Windows and Linux. Has a CLI, some A2A servers and orchestrators, and it's got, of course, an SDK so you can run these agents from your own TypeScript apps. It has built-in context management with references and rules to inform and ground agent responses, and I'll talk about those and demo those in a little bit. It has MCP support for connecting to external tools, and it works with every major LLM provider, cloud-hosted or local. So first of all, it's important to understand that the large language models don't manage context. They don't have any local or recent facts or any memory. They're trained on large amounts of data, and they can give you back answers based on that data, typically not great with factual answers, and certainly nothing that's not in that data set. When you write your first agent application using the chat interfaces, it typically goes something like what I have on the screen, where you say, "Hello, my name is Bob," and it responds with "Hello, Bob." And then you're like, "Oh, wow, I just wrote ChatGPT. This is awesome. I wrote an agent that talks to a model." And then the second question you ask it, all of a sudden it's confused. It doesn't understand what you're talking about because it doesn't have any access to any history or context or any other information. It just has access to the model. So even though you just told it your name, it doesn't have any way to know that because it doesn't manage any context. So the agent is what provides the context. So that the sort of version 2 of your Hello World agent app is you tell it your name. And then the next time you send it a message, you send it the conversation history that was previous to that message. So you're sending it any previous messages, any responses that it may have given you to those messages. And this might be more complicated. It might include tool calls and all kinds of other stuff. But you're basically sending all of the context that the agent needs in every single request so the agent can give you back an answer. So that the model can give you back an answer. The model is stateless. It doesn't have any memory. It doesn't have any idea what you just talked about. So every single time you give it a prompt, you have to give it all the information that it would need to answer that prompt. And all that information is called context. So let's talk about what context management means. It basically means that the way these applications work is that as a user, or which may be a human user or some automated user, that talks to an agent, and the agent talks to the model. And the agent's job is to give the model the context it needs to be able to solve specific kinds of problems, to access certain facts. The agent's responsible for managing all of that context. And the model is only responsible for sort of processing that data that's given to it by the agent, along with its underlying training data, and giving back a response. In the context of TsAgent, our context is the system prompt, which is a prompt that's sent on every single message. It's the chat history. And as I said, this is the previous messages. It could involve tool calls and results from tool calls, anything that's been sent to the model previously, and that may be summarized. And then we also have what we call context items. So these are references. This is a set of documents that are generally used for facts or memory. So these are sort of ground truth facts. We have rules, which are documents generally used for instructions to tell the model how to do something. It might include things like what your preferences are. And then we have tools, which is the metadata for any tools provided by MCP servers. So it'll be the tool name, description, parameters, that sort of thing. So all of these things represent all of the potential available context that we could send with any given request. And now let's talk about the reason we're here today, which is semantic context management. So the problem is you want to create as much context as possible to inform and ground the LLM. You want to give it as much data and tooling as you possibly can to let it solve the problem. But if you give it too much context, that ends up being expensive and slow. And most importantly, it introduces a cognitive overload that degrades the response quality of the model, and especially the reasoning quality. So if you give a giant pile of context, every possible document and tool and rule to the large language model, not only is that going to be expensive and slow, but it's going to give you back a lower quality result than if you gave it the right context that it needed. So the solution is to only include the context items that are most relevant to the given query or prompt. And this is a quote by me, but it's not impressive that Claude Code knows how to apply skills or that Cursor knows how to apply rules. It's impressive they know when to apply them. And if you think about what those Claude Code skills and Cursor rules are, they're really just prompt text. If you pasted that prompt text in a prompt and then along with what you wanted it to do, you would not be at all surprised or impressed that the model was able to follow those instructions. So it's not the following of the instructions that's the impressive part. The impressive part is when you have a whole library of these things, of dozens of them, that the agent understands when to invoke different ones of those relative to the task that you're giving the model. So the model has access to that skill or rule and can apply it when it does its job. And I want to talk about one other thing before we sort of get into the actual solution, which is it's pretty amazing that within the last literally 2 weeks, I've seen a whole slew of solutions to the same basic problem, which is the too many MCP tools problem. And just as some background, generally, especially coding agents, but a lot of desktop agents and other agents they employ a lot of interesting technology around managing the context for things like history and like chat history and a bunch of other things. But for whatever reason, they don't apply those same things to tool inclusion. Generally, they just take all the tools you have configured and they give every single tool to the model every single request. And that's becoming an issue. For example, the GitHub official MCP server by default has, I think, 100 tools, and I think Claude Code only allows 80 maximum tools, so you can't even use the GitHub default set of tools with Claude Code at all. It just doesn't work because it's just too many tools. But it's not unique to Claude Code or to GitHub. Generally speaking, these MCP servers have anywhere from a handful, half a dozen tools to, like in the case of some of the big ones, 100. And that means that if you have even if you have 4 or 5 of these things, you might easily have 100 or 200 tools. And that means that if you're including all those tools on every call to the model, that's the tool name, the server, the description, all the parameters that it takes, all the output parameters that it provides, all that metadata about all those tools is getting sent with every single request to the model, which A, burns a lot of tokens, and B, produces worse results because the models are overwhelmed with all of that tool data. So even when it comes to understanding which tools to call, the models struggle with doing that in addition to the primary objective that's trying to solve. So just as a quick run through of this, StackLock introduced this thing called MCP Optimizer, which is a fairly simple MCP server that sits in front of a bunch of other MCP servers. And what happens is the client gives the MCP Optimizer a prompt. The prompt figures out the top handful of MCP tools that are probably relevant to that and gives back only that set of tools. So it massively cuts down the amount of tokens used. It focuses the clients and the models on solving the problem. Docker has a fairly similar approach with their MCP Gateway product. They have this thing called Smart Search and Tool Composition, where they're able to do a very similar kind of thing to give you back a subset of the tools that you've configured that apply to the problem you're working on. Anthropic put out a paper within the last week that was called Code Execution with MCP. It was sort of a different approach to solving the same problem, which is having your agents write code that calls the MCP server functions as a way to kind of, again, offload the cognitive burden of the models having to understand that all these tools are available. AWS Agent Core has a feature called Semantic Tool Selection. They have these, super high scale agent systems that have thousands and thousands, or maybe I think in one case tens of thousands of tools. And so they obviously can't put all those into the context of an agent, and a model. So they have a technique there to do semantic tool selection. And then lastly, the GitHub official MCP server, which I mentioned, they have so many tools. They started out with a parameter called toolsets. So you could just say, like, hey, I just want this group of tools. So instead of having 100, maybe you'd have 10. But even that was problematic. So now they've recently introduced this thing called dynamic tool discovery, which is very similar to these other solutions where you basically give it some search or some prompt and it figures out which of the GitHub tools are likely applicable to that thing, and it gives you back that set of tools which you can then call. So what all of these have done is they've basically introduced a semantic layer in the MCP server somewhere that's able to filter down the tool set to a much smaller, more focused set of tools. And that's kind of what we've done in the agent side with our semantic inclusion solution in TsAgent. So in TsAgent, we have, again, rules, references, and tools, and each one of those has an include mode. So that expresses how that rule, reference, or tool will be included in new sessions or in requests. And it has 3 possible values. So always basically means every new session, that context item will be included. So these are things that either are just things that really are like ubiquitous, every single request needs to know about it, or maybe things that are pretty important but would be hard to semantically match on. So you just want to be on the safe side and include it. So you make those always. There's another setting called manual. These will never be automatically added by the application or by the agent. You can only get these rules, references, or tools if you add them manually yourself to the current context or programmatically. This is typically going to be for things that you're testing, maybe things you want to pull in and out of context to see how that impacts the solution. But the last one, agent, is really the one that you should use. If you set it to agent, what that means is that on every request, the agent is going to evaluate what's going on in that request, and it's going to find the most relevant references, rules, and tools, and it's going to provide that to the underlying model. And it's super effective. So that basically does a semantic search using local feature extraction to find the most relevant context items for any given prompt. So depending on what you ask the model to do, the agent is going to go out and do a RAG-like solution to review the context items and pull in only those that are the most relevant. And this applies not just to tools like those previous solutions, but to everything, to rules and references as well. And if you're curious about the implementation details, it may not matter to you, but just if you are curious. So we needed something that was lightweight, ephemeral, and embedded, that had RAG-like behaviors, but we couldn't use something like a database or require there to be some sort of model hosting, so we couldn't rely on something like Olama. And the reason is because while we are a desktop app and a CLI that we could probably get away with that, we're also an API. So if somebody uses our tools to build the no-code agent and then they just want to run that agent from their TypeScript app, they expect to be able to just load a node module and run that agent and have it run without having any other system dependencies, without having to install anything else or have any other service running. So we needed something, no services or subsystems, that ran in memory, that was pretty fast, and that produced high-quality vectors that were comparable to the quality of the feature vectors that you would get from a hosted solution. And we have a solution that we think sort of meets all those, checks all those boxes. It uses transformers.js, which used to be from Zenobia, I think, and now it's part of Hugging Face. We use this all-mini LM model. It's a 6-layer, 22 million parameter, 384-dimension Onyx model. It's only 80 megabytes. So if you think about these feature extraction models are way simpler and smaller than the text completion models, like what you think of typically as an LLM or a small LLM. These things are pretty light and fast. This technology has been around for a while. So what happens is when we're in agent mode, we index the context items just in time. So we chunk them up and index them only at the point that we need to determine if one is relevant or not. And one of the benefits you get is that you don't have to pay any of that indexing cost if you don't actually use it. And they're also cached, so if you use them more than once, which would be typical, you're only going to have to pay that indexing cost the first time. And it's pretty fast. It's in the maybe small hundreds of milliseconds to index a pretty large amount of data. And then for searching, what happens is on request, we have a semantic search function that we take the prompt and do a little processing of the prompt and then send that in to a semantic search function that we evaluated a bunch of different things, but it turns out just doing the brute force cosine distance KNN calculation was super fast with this technology. With about 50 rules, references, and tools, generated about 175 encodings, embeddings, and we were able to search those in sub 10 milliseconds on just a MacBook, a regular MacBook. So it's pretty fast. It's fast enough that it's not worth having something like a vector database to do this kind of stuff with. So let's do a quick demo. Okay, so let's look at a quick demo. So first of all, we'll do a little refresher on how these things work. So we have references. So this sort of explains what references are, and we have a whole bunch of references. So these references are all about the TsAgent Foundry product. So that's sort of about how TsAgent works generally, but particularly about how the Foundry product works, the desktop app. So we have a whole bunch of references. These were all just things pulled from existing documentations. They were actually created automatically by the agent itself. So I basically said, hey, go look in these directories, pull all these files, and build your own references, which it did. We have a series of rules, which are pretty straightforward. This is a set of rules primarily to direct the agent about how to build the website for the product. So the initial demo that I did a couple months ago was showing how we use TsAgent to build its own website, and these are the rules required to do that. And then we have a set of tools, and these are just regular MCP server tools, so you can sort of see what they look like. And in each case, for what we have is, so for example, for the file system tool, we'll go into edit. We have this tool enabled, and the server default is agent. So this is the tool, basically the tool include mode. So we can set it to always manual or agent, and then on a given tool, we can override that. So we can either use the server default or we can set it to always manual or agent. So for every MCP server and every tool, we can basically say, do we want it always included in the context? Do we only want it included when the agent thinks it's relevant? Or do we want to do it manually? And the same thing works with rules and references. So I can go to reference and see most of these are set to agent. And let's do one other thing. Let's go into settings, chat settings, and look at how agent context selection works. So again, you never have to touch any of this stuff. You don't have to worry about how it works. But if you do want to test and tweak it, you're certainly welcome to. So we have some settings. You can control how many chunks we're going to match when we look for the most relevant context items, how many we're going to select, and then also a score threshold. So you could sort of say, hey, I don't want to get more than 5. That's going to defeat the purpose, or maybe 10 is a better number. But if they're really solid matches, maybe I do want to get more than that. So you might say like 0.7, it's a 0 to 1 scale, and 0.7 is a pretty strong match. So you might say, well, I don't want to get more than 5, but if there are more than 5 that are really strong, I do want to get all of them. So these are essentially the settings that you can put in place for how the agent context selection is going to work. And again, you don't really need to worry about that. It just kind of works magically, and these defaults are actually pretty good. So let's go look at a chat session. So a couple of things. If you've used the product before, you'll have seen these before. So first of all, we can go to settings, and we can see, yeah, we have those same agent context settings, so we can override them on a per chat session basis. So if you just wanted to, let's say you wanted to test what it looked like if you changed some of these parameters around, you can easily change them and revert them. And then we also have the context. So this is the context that's available to every message in this session. And as you can see, we only have one reference, which is this overview. We have one rule, which is this one called do it. And then we have one file system tool, which is list allowed directory. So every single request is going to get this set. And I can add and remove things to this manually. So I can go in and say, like, well, what if I wanted to add, another reference? I could do that. Or if I wanted to add another tool. So I have basically all the tools that I might have in any of these MCP servers. So I can control which things are built into every request through this, and I can inspect and see that. And that's part of the reason that we built this application is we really wanted to have good visibility of exactly what was getting sent to the models in every prompt, just so we could understand what was going into generating the responses. So let's show now kind of how this works. So let's ask it a simple thing like, what directories can you see? And so there's just a slight performance penalty the first time you run one of these things that's going to go index everything. So what we can see is that it called list allowed directories. It figured out what directory you can see, and it actually used some of the rules and references to tell us what's in that directory. It didn't actually look in the directory. It just understood from some of these other documents. So there's a new little icon that you may not have seen before. This will view the context for this response. And so now I can see, okay, so for this particular request, these are the things that were included. I had the overview, which I knew. It included this thing called assets. That was agent included, and there's the match score. And then it included some tools other than the ones that I had told it to include that were the most relevant. So now I can see exactly what was used to generate this request. And it did pull in an asset that I didn't really think it was going to pull in, but it did. And that asset actually does explain what things are in that directory. So that turned out to be super relevant. So let's do a slightly more complicated example. So I'm going to ask it a question about the product. How do references work? The indexing will be fast, but the query is going to be more complicated. Okay, so we got back a pretty good answer that explains how references work. So it tells what they are, the different types, the properties of them. There's our always agent and manual that we just talked about, how to use them, some examples, which is pretty cool, and then it's kind of an overview. So that's exactly what we wanted. So let's see how it did that. So in this case, we're looking at the request context, and it looks a lot different than the last one. So this one, it pulled in a reference called references system, it pulled in one called tsrefs, one's tsrefs about. So these are things that you'd think would be references that are about how references work. It's a little meta, but and it also pulled in some tools. So there's some internal tools for creating and updating references. It didn't actually call these tools, but maybe those tools do sort of map to what this topic is. So we can sort of see those got called in too. So the general idea is whatever you ask it to do, it's going to go try to find the most relevant context items. It's going to pull those in. And then if you want to dig into just sort of testing and tuning and make sure it works the way you think it ought to work, you can go into each request. And on each request, either from this app or over the API, you can basically say like, hey, I want to see exactly what the agent pulled into the context for this particular request to generate this response. And you'll be able to see the things that were either always pulled in or things that the agent pulled in for just that request and exactly the score and sort of why it pulled it in. So it's kind of the gist of that. All right, so the summary is we can use no-code tools to build highly skilled and knowledgeable agents that have access to large bodies of references and rules and large tool sets. So you don't have to worry about trying to trim down this amount of information you give it. You can overload the agent system itself with as much information as you want because it's going to be intelligent about understanding what to pull in to solve a given request. And so you can do things like point the agent itself. You can have the agent go build its own rules and references by pointing it at source code or documents or the internet or whatever, and build these big internal sets that all get indexed that get pulled into context when they need to. And then the second one is the semantic inclusion only presents the agents with the most relevant context. So why is that important? First of all, it means you don't have to be selective. You can just load up these larger knowledge bases and tool sets with all the information and all the tools you might possibly ever need. And the agent's going to be smart enough to figure out how to use the correct ones without, overloading the context windows and producing a cognitive burden to the models. The requests are smaller and faster and less expensive, and they produce higher quality results, which including better reasoning because they're way more focused and the model's able to sort of do its job. So all in all, this is a feature that I had designed at the very beginning when I built this framework, and it's just been a to-do list that's been nagging, to-do list item that's been nagging me for a while. And I was inspired by seeing all of these other companies get into this space of putting some semantic layer into their MCP servers, and all right, it's time to put that into the agent. So having done that, having tested it a fair amount, it's super powerful. It's really easy. It just works out of the box. You don't really need to know how it works or touch any of the settings. You can literally just add rules, references, and tools, mark them all as agent include, and everything just kind of magically works. It's faster, it's cheaper, and the results are better than they used to be, which is all pretty awesome. It's a win-win-win. Anyway, I hope you enjoyed this. If you have any questions, feel free to reach out. Thanks.